All right, calculus students, pre-calculus students, and especially general seekers of truth. In this video, we will answer a very general question. Let f of x equal x to the nth power, okay, where n is some sort of integer, and we want to find or evaluate f prime, okay, the derivative of f of x. Now, one of the things that we do know is that we can apply the limit definition of the derivative, in other words, the difference quotient, f of x plus h minus f of x, all of that over h. And then we can, of course, apply the binomial theorem, and here's where the power of the binomial theorem comes in. We don't know exactly what n is, but we know that it will follow a certain pattern. So when we apply that definition here, x plus h quantity to the nth power minus x to the nth power, all of that over h. The binomial theorem tells us that this part right here can be expanded as follows. It can be expanded into n choose 0, x to the nth power, h to the 0th power, plus n choose 1, x to the n minus 1 power, h to the first power, plus n choose 2, x to the n minus 2, h to the second power, and so on. So I'm just going to say dot, dot, dot here. Wherever it stops, eventually we're going to end up with n choose n, x to the 0th power, h to the nth power. And we still, of course, have this minus x to the n at the end here. And what we're doing here, let me just draw a line here, we're taking the limit as h approaches 0 of this expression all over h. Now, let me just continue and expand and simplify some things wherever I can. So all of this stuff here, n choose 0 is just 1, x to the n is x to the n, h to the 0 is just 1, plus n choose 1 is just n. This is x to the n minus 1 times h, plus n choose 2. I actually don't know what that is. N choose 2 is a lot different depending on what your value of n is going to be. H squared plus dot, dot, dot. N choose n is just going to be 1. X to the 0 is 1. And so we have just h to the n. Then we still have the minus x to the n at the end. All of this over h. Okay. And once again, the beauty of this is that we have x to the n and negative x to the n, and that is going to cancel. And now you might think, well, what about the rest of this stuff? Well, rest assured, that stuff is going to be able to have some simplification as well. So if you notice here, all of the terms that are left, they all have an h in them. Okay, this is an h squared, all the way h to the n. So what we could do is we could factor out an h out of the numerator, and let's see what's left. Well, n x to the n minus 1 is still there. This h here is going to go away because we factored it out. Plus n choose 2, x to the n minus 2, that's still there. This h squared here will just become an h plus. And all of the h's that are in this dot, 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 it just symbolizes us following a pattern. H to the n will now get reduced down to h to the n minus 1. And all of this gets just completely divided by h. And once again, we can cancel out these h's. And now, because we have got the h out of the denominator, we can substitute 0 for all the h's. Well, let's look at again and see what happens when we substitute h equals 0. This h here will become 0, so this entire term goes away. This h here is 0 to the n minus 1, that entire term goes away. And then we have a bunch of terms in here that also have h's in them, in this little dot, dot, dot here. So they're all going to have zeros in them, and they become 0. And the only thing that's left, the only term that's left is that one, because it doesn't have any h's in it to begin with. So all of this gets reduced down to nx to the n minus 1. And this gives us a generic formula for evaluating the derivative of any power function, So let's just take one more quick example. Let's say that you have g of x is equal to x to the 20th power, right? And let's see how our rule applies. In our example, n is equal to 20, so that means g prime of x will equal 20 times x, and then we're taking one away from this power to the 19. Okay? So it's nice and simple. Once we are able to apply the generic rule of the derivative of a power function. So this is one of the basic, one of the first theorems and ideas that we have in taking derivatives in calculus, and it's going to be incredibly useful to us. It turns out that this rule works for non-integer values as well. It works for negative numbers as well, but we'll continue to explore that a little bit when we get to some more calculus concepts. As always, ask for help if you need it. Thank you for watching, and have a wonderful